Okay, this most of this, this is quite long. It's an hour and a half long. Most of it's just about, how they sort of figured out what they were going to do and how the team got organized and all this. But when I got out to this point, and this is where they're starting to analyze the data. Now listen to this. This is kind of funny.
Evolution, the atmospheric evolution, the interaction of the two, that somewhere different kinds of molecules form, and it's somewhere they may become life and so forth. So that's the sort of thing, in general, that I'd hoped we would talk about.
Well, I hope you'll be glad to know that for this complete survey of all of human knowledge, considering all of the planets, we have allowed you half an hour.
Martin made Lee a key player in the mission, assigning him the role of coordinating science analysis and mission planning. That meant leading the science team to consensus. It was like herding cats, one person said. Very smart, but very independent cats.
I had all the scientists and all the mission analysts under me, and as I often tell people, I had 2 Nobel Prize winners and 4 who took me aside and explained why they should have won the Nobel Prize. It was quite a group. It was quite an adventure.
There were other jobs Martin gave Lee, including running political interference.
Then it goes on to, but that's the kind of thing, I'm telling you right now, you come with any kind of opposition to what they've already decided and you're just out in the left field. Now, this guy was assigned to herd those cats around. Trust me, if he just stood up and said, hey, I want you cats to listen to me, he'd be out in the woods somewhere. All right, so most of these cats got their minds made up already, so you're not going to hurt them too much. However, as they go to land out there on Mars,
1976 would be the 200th anniversary of the Declaration of Independence. What could be better than to celebrate America's bicentennial than landing on Mars? That was the expectation. And as scheduled, Viking 1 went into orbit and began sending back images of the proposed landing site. What the pictures revealed was a shock.
All right, this is where we're going to get into what the pictures really do reveal. All right, so now here they are up landing on Mars, and here's President Ford giving everybody his best.
Very best, will you? And let me express to each of you and all of the group my very best wishes for a great job. We're all very proud of you.
We appreciate those kind words, Mr. President. Thank you, Mr. President. Bye.
Goodbye.
Thank you.
The enthusiasm for more Martian missions proved wishful thinking. Although Martin's team had achieved an enormous engineering feat in the successful landings of both Vikings, the primary science mission, the search for life, was inconclusive at best.
No, not at all. All right, so they don't know how to read the rocks, so they saw no life here. I understand. If they could get close-ups of these rocks, I can tell you what they were.
And discouraging for many.
Not just that there was no life, but there was no organic material, and that the
Now let's listen to this part. Apparently they didn't think there was any life at all, no organic material. There was nothing up there but what they considered to be inorganic material. And I'm going to tell you something right now. There is no such thing as inorganic material. None. There's processed organic material turned into metals and plastics and all that nonsense. But when you come up on a landscape like that, that is 100% from organic.
For life was inconclusive at best and discouraging for many.
not just that there was no life, but there was no organic material, and that found out the explanation was that Mars was self-sterilized. Nobody expected that. I didn't. No one did.
But circling over the landers were the Viking orbiters. They provided 6 years of continuous monitoring of Mars and once again changed our understanding of the planet. Here was a planet not only of craters.
Do you see that? Do you see this? I just showed this. That is the vein and that is the artery, and this is an attachment for a tendon anchor. I'm not kidding you. Now, they talked about no biology, no organic, nothing of this. Well, I'm going to tell you right now, it's 100% organic, and I am going to show you life, without question, was there, and apparently was wiped out. Now, this is a tendon enthesis, which is an anchor for a tendon. It locks in bone, muscle, and that type of thing, and then a strap comes out. When they break flat as a pancake. This was a video I was just doing. This is just amazing that this thing about Mars came up. Now listen to this. Side of this attachment, they come, as you saw, maybe like here or right over here. I'm not certain. Those are the blood supplies. The red blood, the black blood is probably right there. I don't know. But now watch this. I showed you. Well, here it is right here. Let's just look and be sure you don't miss anything here. Whoops. Let me get a nice clear. All right, here, this is nice and clear. Now, if you go back and you look at that anchor that is on Mars, it's even got this same structure that allows the blood, the red blood, to flow in. It's got that same little structure on the side. You look, and then it's got the circle, one over here and one over here, which is the red blood and the black blood. And that's the anchor, and that's a tendon ball. And I showed this in great detail. I have the tendon ball right here somewhere. Here it is right here. And that's the anchor right there. It's just not wet now. If I make that wet, you'll see all of that detail. And of course I have to put it in a microscope. It's identical. And they call these the thunder eggs out in Oregon. It's Oregon State stone. Okay, this is what they are. That's the stalk, what we saw, and there's even that little cutout. And here's those two black and the vein and artery spot, and it breaks away just like this. Let me show you one anatomically. I think I might have shown you, but I'm going to show you again. Don't forget. Remember what we just saw a second ago. It's exactly the same thing. If you look really careful, you can see the rim around there. That it's just like the rim on the other one. So that's exactly where the detachment came apart, and these are the center cord that ran in that center spot. And these are those tendon entheses. That's exactly what they are, and they are everywhere in a creature's body, and Mars was a creature's body. Okay, let's see if we can determine if there was ever life on Mars. These are what they call the Mars Blueberries, these little blue-looking spheres. Now, look what's underneath what they're laying on top of. Because I'm going to show you these on Earth. It's the exact same thing. Okay, first of all, here's what these stone balls look like. On the outside is that real blueberry look, and on the inside is almost like sand. Now, they are, hold on, let me find the whole batch of them. Alright, this is here on Earth. These are the exact same balls. It's exactly like the Mars Blueberries, and they are on the same exact substrate. Now, what is this? This is mud. Now, on Mars, you don't have a lot of moisture, so you have abrasive erosion. That's why there was just nothing but this look to it. Here, the skin and flesh that these were anchored in has eroded, and you end up with mud. Let me show you what anatomically these would look like when they are still alive in the flesh. Okay, those black balls that you saw are these black balls right here. And the basement layer that they were laying on is a layer of tissue underneath. This is what basically you would call a membrane. You have skin or mucosa, intestinal lining, whatever, and then you have these pockets of fluid anchored in these flexible, collagens, but they're anchored so that they always come back to where they're supposed to be after they're stretched and pulled and all that. Well, guess what? They get very, very, very large. You said to me, "Ooh, Roger, how could those Moki marbles, those blueberries and so forth be? They're as big as your fist." I said, "Well, that's tiny." That is nothing. That is minuscule compared to what they can be like, similar to this. All right, that is on the coast of England somewhere. And this is the mucosa. That right there is the interstitium, which is all that fluid-filled bags and anchor balls, and the balls have eroded. It's been eroded backwards, and all these balls, which are not really, these are tough as hell. They just don't erode. You see all the mud here? That's all this is turned into mud. Mud is nothing more than eroded flesh. It's all it is. It's eroded bodily tissues. That's what mud is. Get used to it. We have no idea what we're living on at the moment. This is just gigantic biology. The Earth was, Mars was. I believe everything there is was at one time some form of biology. Let me show you why I can say that, especially about Mars. All right, I'm going to show you something on Mars that's going to freak you out. What would happen if I stretched this way? These things would flatten out, right? It would like, or let's say I pinched them together. These would all squish together, and some of them would be stretched and some of them would be pinched. Correct? Yes, Roger, you're correct. Thank you. All right, remember those balls and straps? These are the balls, these are the straps. You see this is stretched out here? And these are all squished up together. Remember I said if your skin was squished this way, it'd be all crunched, and if it was stretched out, it'd be like this. But they will always come back into a nice, even, something similar to this, where it's not pinched. These are pinched. These are stretched. That is skin tissue, and that is Mars. All right, and see, it's like sandblasted. This would have been at the basement layer, but it's not like, it doesn't look exactly like the other basement layer because this is basically sandblasted. Now the reason the balls don't go away, you see the balls down here? They're tough. They're very, very tough. And the straps are not quite as tough, and the rest of the stuff is real floppy. Now, let me show you the piece de resistance. Okay, so why do I say the piece de resistance? Because this is over the top. This is the thing we're looking at down here. And it is embedded right in here in these little, whatever they are. I know what they are. This is the blow up of it. Now, I'm going to tell you right now, I am as deep into anatomy as anybody ever has or will be. I know literally everything about the human body, how it's structured, all of the, everything in it as far as even the molecular compounds that build all these things, and everything is serviced by blood, obviously. Blood has transition metals in it, which have little tiny pinchers on these transition metals, and they carry things around in your body, deliver and pick things up. That is the mover and shaker in your body's transition metals. And they are red and black and blue and all these different colors in certain places where there's aqueous. However, when you get into like this, they just turn into their bland colors, which is the color of blood, red, and then there's black too, and then there's the muscle fibers, which are the connective tissues. The red blood is very weak and it just erodes right out. That's why you see all these cracks here. These are what's called muscle sarcomeres. Sarcomeres. These are bundles. And what they will do, you see how this is separated from that? They'll pinch right together. They'll pinch right together. They pinch together. That's how these things, that's how a muscle works. Zip. Now, it has to be fed with blood, and that is the blood it's fed with. And these are the little blood vessels that run into the tissues to let the blood flow through there. This one up here is the vein. That one's coming back up to the heart. That's why it has no legs on it. They say this is a Mars crab. Well, obviously it's not a crab. It's in the side of a muscle, sarcomeres. Let's look at this in the anatomical. Like I said, anybody, I don't care who it is, an anatomist, a doctor, a physicist, I don't care. I want somebody to talk to me. This is crazy that they can just turn away from reality like this. Even though it is so spectacular, it's scary as hell. Yeah, it is. Scarier to me is the ability to just walk around in circles and be very perfectly happy deluded like that. All right, before we see this other thing, I want to show you this. This is a muscle rock, a big rock that's in my shop, and that is the abrupt transition. That is literally an artery. This was flush with red blood. You don't see the vein. It might be right up in there, but That's the artery, and all of this was flush with blood. This is the same muscle tissue that is in muscles. I mean, that's a muscle. And these are the abrupt transition where the muscle begins to transition from very, very mineralized to just the red bloody sarcomeres. And I'm going to show you that in a second. All right, so I'm showing you smaller things and bigger things, but they're still rocks, and there still were biology at one time. That is muscle connective tissues. This red stuff running out of here and all over, that was the blood that serviced this muscle. Now let's take a look at sarcomeres, and I will show you how exactly similar, well, they are exactly the same as the Mars crab, and they are the same as Petra in Jordan. All right, this is just a little doodle that shows that when they're relaxed, that both sides are pulled apart. When they're contracted, they pull in, and they're showing layers of blood in between, and that just runs out because that's the weak part. Now here it is right here. These are the sarcomeres, and this is the actual sarcomeres themselves, and this is contracted and this is relaxed. Now remember these ridges? Remember this dark and this light next to each other? Let's see if we can find that on Mars, and then we're going to see if we can find that in Petra. All right, you saw the doodle, you saw the anatomical. These are the breaks in the sarcomeres. These are the layers of connective tissue. All of this red running off stuff that's laying on the bottom, that was the bloody layers in between the connective tissues. And that is the feeder, which was the artery, and of course the vein is running with this. And that's what this is. Now, let's take a look at Petra and see if we can see the same structure, which we will. All right, this is Petra in Jordan. And it's spectacular, and nobody understands much about it. However, it's carved out of a muscle. And you say, oh, come on, Roger. I say, yeah, that's exactly what it is. And you see over here, these are the sarcomeres. You see the dark and the little flappy little bits again here? And you see the light, and you see the blocky shapes that these are in? Those are sarcomeres. Now, they cut little ventilation holes. Well, here on the side are even easier to see. See the block, see the block, see the block, see the block. But there they are right there. That's the sarcomeres. And that would erode away just like it did up on Mars. And you'd see these sarcomeres. Now, so if this is bloody tissue and you went inside of here, what would you see? Well, you'd see some more bloody tissue. Well, let's go inside and see what we do see. Doesn't get any bloodier than that. These are that's blood vessels up there, and that's red blood. You got some black blood over here. You got all kinds of connective tissue going on here. These are layers of tissue. It's as simple as that. We live on biology. Mars was exactly the same biology. Velikovsky recorded the events that destroyed Mars and almost destroyed Earth. And that's why all of these gigantic creatures, which were creatures that appeared to have been alive somehow, I cannot account for the sizes, they were just so enormous. There was ancient texts that talk about them being miles tall, and that is not an exaggeration by any means whatsoever. And I have found nothing on this earth that is not biological. Zero. And I have looked as hard or harder than anybody in history. And I have a lot of tools to look where they never had them before. Okay, the things I showed you, all the biological stuff that's on Mars, the Mars Blueberries, the Mars Morse code, the crab, all of that stuff was from the first mission, which was the Curiosity. And they had sent a rover up, and it went around and took all those pictures. I told them, I said, you got to look at this, you got to look at this. No. Nobody ever would look at it. They sent another one up, Perseverance, and they still can't understand what they're looking at as biology. And here they're showing how these things go around the surface, and they look at this, and boy, they focus in on this and that. Obviously, this is some little, cartoon type thing they made of it to show you what they're doing and how they're, and it did. It went all around like this, and it could focus in on stuff, and I think they actually drilled holes in some stuff and things. I can't remember now, a long time ago. This was over 10 years ago. Well, I guess about 10 years ago. Now, obviously, this is not the actual rover, but it's looking around and it's pointing in and looking at these crazy things and thinking, wow, what is that? And it's got all kinds of little special instruments that they could tell what, to some degree what they're looking at, but they just can't get it around their mind to believe what they're seeing. And I have been very pushy about showing all these things. They're looking at this, saying, oh, what is that? What is this? What is that? Well, guess what? It's muscles, my friend. The sarcomeres, tendon balls, interstitium. And what you are driving on right now is eroded blood. You see that? That was 11 years ago. January 2011, this video is from. So by this time, you would hope somebody would pay attention to what is so obvious. And like I say, I have been forcing this, and I've been blocked basically everywhere, and I've been put on spam lists because nobody will listen. So it's up to you to start to say to people, hey, we need to be real here. These budgets are billions and billions of dollars to go walk around in circles. I don't think that's a good investment. I know, oh, Roger, ruin everybody's party. Well, maybe not. We could take a different tact. Right? You don't have to just stop what you're doing. We just have to understand what we're doing a little better. How about that? Maybe that would work.